Okay, good morning, everybody. This lesson is about the design stage. So that is step 5. Okay, so municipal processes step 5, and there are actually a 5A and a 5B. So we'll get to that just now. Right, so what is design? Well, firstly, we have distribution network design. So that would consider the design that everything of this wires network that can take the electricity from generation to the end customers. And what is the generator plant design? Well, it's designing the details for this generation plant. So from a systems engineering concept or point of view, planning is when we decide what lines we need, what transformers we need, and that gives you the specification to do the design with. So that's the design specification. During the design process, you actually get to the equipment specifications. So that is where you say, okay, I'm going to use the hair conductor, I'm going to use the transformer with this parameters, etc. Okay, so what I call 5A is the distributor network design. When do we need to do the design? Is planning has identified that you require grid strengthening or upgrades. The customer or generator has accepted the budget quote. Then you do the network design and you design the interconnection equipment. So the distributor at this stage selects and specifies the equipment to be procured and installed, provide the necessary guidance to the customer to design and install the interconnection equipment from his side, and proceed with procurement. And of course, within all of this falls all of the approval processes, which is the technical approvals as well as the financial and economic approvals. Now, the document doesn't go into a lot of detail because even though there's some extra equipment that you didn't necessarily use as default in a normal planning, distributor network design is a standard process. You do that all the time. Just follow the same process. Okay, we've already discussed it. So select and specify the equipment and eventually proceed with procurement. If there is self-build, then that means the distributor isn't going to go through all the phases. The distributor has specified from the planning stage what is required. The customer is now going to do the design, procurement, and construction. And at the end, all that equipment that the distributor would have constructed gets handed over back to the distributor. So it becomes the distributor's asset. Why is that important? Well, because if it's the distributor's asset, he needs to take care of it. Maintenance, refurbishment, everything. And that is why the distributor wants to keep a close eye on the quality here. So the customer, even though he does everything, he still follows the distributor's processes, all approvals, all specifications, and quality control, exactly the same as if the distributor would have done it themselves. Then step 5B is the generator planning and design. Okay, so this is maybe a little bit wider than what we typically regard as design in the distributor environment. Also note to what we've discussed before. This would include the grid code compliance aspects because the generator especially have to design for grid code compliance. They cannot just put a generation plant together and at the end come and say, oops, I didn't make the grid code compliance requirements. So, firstly, the customer is going to undertake the necessary studies for the point of connection impact. It's not the full grid impact, it just looks at the point of connection. Then they will undertake the impact assessments on the generator collector network. I'll show you just now what that is. Undertake the interconnection equipment design, if that's required. Grid code compliance simulations. Design the generator and related infrastructure and specify all the equipment. So design of this collector network. That is also quite interesting. So let's look at an example of a collector network. In this case, you will see this is typically of a PV plant, where you would see there's an inverter, there's another inverter, and very often there are two of these connected to a 3-winding transformer that gets connected to a piece of AC cable that ultimately goes back to the point of connection. So the grid impact is done at this point of connection. The collector network is all of these AC wires and bus bars and terminals that goes from the transformers, well, including the transformers, back to the point of connection. The interconnection equipment is that equipment that connects between the customer's assets and the network. And grid code compliance, of course, is always at the point of connection. The difficult part here is if you have a load as well that's connected somewhere here, how are you going to split that? We will talk about that in the grid code compliance, but then you select a point that is a point of utility connection. So that's the point where this generation plant gets connected to the utility. Okay, so what the developer or the customer will do is design and specify all of this equipment. In the first place, with load flows to make sure that voltages within this entire network remains within spec. Also that all equipment are thermally adequately rated. Then they will do short circuit studies to make sure that all equipment can be protected. A losses evaluation is a very good idea so that you make sure you don't have an inefficient generator. And of course, grid code compliance. So you design this plant so that you can meet the grid code requirements. The critical thing that often happens is the reactive power requirements. Due to all of these cables, they don't meet it and they actually have to change the design. Other aspects is voltage regulation within the plant. So it's very important that they do these designs upfront and the studies. Note that the distributor has nothing to do with this. The distributor wants to see that they meet the grid code at this point from a simulation point of view. But for the rest, it is not the distributor's responsibility to know what happens inside this plant. All right, so there we do have responsibilities. And you will see that I've highlighted some of the key aspects. There's a distribution network, protection, interconnection equipment, collector network, power quality, grid code compliance, and metering. And in the activity just now, we will look at who do you think is responsible during the design? So to summarize, the distributor's responsibility is the network design. That's any upgrades that's required to the network. It's the protection that needs to be upgraded, typically for the generator as well, so that you now have dual direction. Make sure if there's increased fault levels that is dealt with, as well as the metering. The generator takes responsibility for the collector network, the equipment with inside the generator, the network impact, so voltage changes, things like that, and the grid code compliance. So in terms of responsibilities, some of these aspects is just the distributor's responsibility. So distributor network, the protection, metering. Others are both parties' responsibilities, where, for instance, on the protection, you would collaborate because you want to coordinate the protection between the two plants. But be very careful. Whatever the generator submits to you in terms of their plant design, you can ask for it, but you do not approve it. So you do not take that responsibility. So thank you, and we will have the Q&A session and the quiz later.
Thank you, Gerard. Okay, so the floor is open. Any questions, comments, responses? Share, like, I think let's do it again in the chat. Even if you say there's no questions or it's clear, please do that now. Otherwise, you can just unmute and ask your question, or yeah, share your question if you have one. Thank you.
Therefore, I think then, shall we do that poll?
Yes, let's do that.
Just put that slide up again as well.
Okay, so to some extent, if you listen to what Gerard was saying, he was actually giving you the answers to the poll. So let's see who was listening. Okay, I'm going to launch it now. Could someone just confirm? Can see it?
I see you've sent it.
Yeah, it's up on the screen.
Yes. So there are 7 questions, and each one of them, you see, I can't move that, takes one of these aspects that's on the right-hand side, and it asks who's responsible during the design phase for the embedded generator. And you have the option to say distributor, customer, or both. So the first question is, who's responsible for the distribution network design? Shall I go through it, or do people just
No, they
follow
first
at
need
their
to
own time?
they first need to respond. So we're encouraging everyone to give their responses. I think it does allow you to give a response. Please do that now. And I just submit your responses. Okay, there we go. I see there's other responses. I thought it's just mine, but there's other people responses coming through now.
I think you have to accept the poll. You will see in the chat that there's a view poll that you can access it from there as well in the chat.
Yes. It should be popping up front, or you can access it at the end. I think I'm going to stop the recording.